Hi friends, welcome to Unacademy. Myself Bhavani. Unacademy is one of the largest teaching and learning platform. As you all know, Unacademy offers plus courses, plus four. The plus course is meant for Karnataka CET students who are writing CET exam in the year 2021 can subscribe these plus courses. Now, what are the benefits of plus courses? You will have structured live courses, that is both class 11 and class 12 topics will be done in detail. Students, all the topics of class 11 and class 12 that will be done in terms of competitive level exam. The tips, the tricks and the concepts will be explained in detail. These sessions also include live doubt clearing session. When you learn a particular concept, you will have plenty of doubts. So you can clarify those doubts during your live doubt clearing session. There will be also quizzes, students. Quizzes for, once you finish the topic, if you want to analyze yourself whether you have learned it well or do you have, some more studies required. So all those things, your own, you can do your self-analysis. Number of batches have begun. Therefore, see to it that you will be joining any one of these batches. When you join these batches, kindly make use of the code Bhavani Live. This is having a discount. You can use this code and get the discount. Apart from all those things, we also have a daily practice paper, so that you don't study and leave it. Every time you go for a very good practice. And also we have full length mock tests. All these are with analysis. For a single subscription, you have unlimited access. So plenty of educators, a number of batches, plenty of courses and, large number of lessons. All these are, every day these are happening under Unacademy. Students, therefore, kindly see to it that you will be joining these, the plus course, and you will be enrolling your name. You can even inform your friends, your classmates or juniors regarding the plus course and help them also to join the plus course. Now we have the comprehensive batch for the year 2021, which has already begun, student. So you can join these batches. You can enroll your name. There is a Kannada batch also, so you can join the Kannada batch. If you are comfortable with Kannada, you can join this batch also. But while joining, make use of this code and get the discount Bhavani Live. There are different plans. So one of the best plan is 12-month plan at the rate of 12,375. You need to pay 1,031 per month. You also have a 6-month plan at the rate of 10,125, and it is at the rate of 1,688 per month. So complete syllabus will be discussed. All the topics will be done in detail. There will be doubt clearing session also. So those who are comfortable with Kannada, you can join this Kannada batch. As you can see, we also have the champions batch, and the champions batch for the years KCET 21 has already begun from 15th of October. So in case if you are interested, you can enroll your name. There is PCM. We also have a combination PCMB and PCB. So students who are interested, kindly see to it that you will be joining any one of this batch. You will be enrolling your name for any one of these batch. Okay. And also see to it that you are, using the code do not forget to use the code and get the discount. So Bhavani Live, this is the discount. Okay. You also have from November 2nd, there is a practice test also. There are many free practice tests, and students, that it's not enough if you just learn and keep. You have to keep on writing the test. That will increase your speed and also will help you to solve the question in a better way. So as many as tests you need to write. So see to it that you are enrolling the name for the test. These are free tests, and you have to write attempt it live, and this will help you to crack CET with a greater ease. So I have been students, not only that, I have been taking YouTube session. So students who are joining me today for the first time, see to it that you are watching all my YouTube session. And mock tests I have conducted. I also take special class under Unacademy platform. So kindly watch those classes also, because they are also free classes. Whenever you like the class, do not forget to press the like button and also press the bell icon so that you get the notification. Kindly go through my description box. You will find various links to join all my previous classes also, and also you can join the future classes. Okay, you will get the necessary links. So today I will be doing chemical bonding. I have been taking chemical bonding mock test. So one more mock test I will conduct, and my next class will be on 12th student, where I will be starting with elements, that is S block elements. Okay, so we will start with today's class. So let us go to question number 1. Now we'll see question number 1. Among lithium chloride, rubidium chloride, beryllium chloride and magnesium chloride, the compounds with greatest and least ionic character respectively are. So there are 4 examples given. You have to find out which one has greatest ionic character and which one has least ionic character. So we will try to find out now. See, it is alkali metal is given. You can see here lithium chloride, and down the group rubidium is also given, and the charge on lithium is plus, rubidium is plus. Okay, and we know that as you go down the group, atomic size increases. So rubidium is larger in size compared to lithium, isn't it? Then you have from alkali earth metal beryllium chloride. So the charge on beryllium is +2, and you have magnesium chloride. Okay, the charge here is +2. So atomic size increases down the group and it decreases along the period. We all know. Here, if you can see this, atomic size increases from decreases from lithium to beryllium. Then from beryllium to magnesium it increases. So which is the one which is having the least atomic size? That is beryllium. The size is small and the charge is more. According to Fajan's rule, smaller the size of the cation, and greater the charge, more is the covalent character, isn't it? So among the 4 example what is given, beryllium chloride is having highest covalent character. That means this is the one which is having least ionic character. So beryllium chloride has least ionic character. So smaller the size, that means exactly the reverse you have to now find out. Larger the size, which is largest among the four? Rubidium, isn't it? Largest size, therefore this will have greatest ionic character. So maximum ionic character is shown by rubidium chloride, whereas the least ionic character is shown by beryllium chloride. So the answer will be option B. Option B is the right answer. I hope it is clear. Students, whenever you know the answer, you write it in the comment box. Okay. Okay, we will go to question number 2. The species in which nitrogen atom is in a state of sp hybridization. So where do we see nitrogen having sp hybridization? Now how do we find out? One of the way is to find out the number of hybrid orbital. What is the formula? Half into valence electron on nitrogen. You know nitrogen is having atomic number 7. So 1s2, 2s2, 2p3. The outermost shell is the second shell which has 5 electrons. So valence electrons are 5. These are not monovalent atom. These are divalent atoms. So nothing to write. Charge you have. So minus 1 means plus 1 it becomes. So 6 by 2. Correct? 6 by 2. So 6 by 2 means how many hybrid orbital you are getting? 3 hybrid orbital. Which hybridization gives 3 hybrid orbital? Which one? sp2. So nitrogen is sp2 hybridized. So we are sure that this is not sp hybridization. Now we will see the next one. Half into number of valence electrons are 5. Okay. So minus plus 1, that means once again it is sp2 hybridization. Correct? Okay. NO2. Now NO2 you cannot find out like this, because 5 you will get, so 2.5. This is not the method. Under such case, when you cannot use this formula, students, what you can do is you can write the Lewis structure. Now for NO2, nitrogen has how many valence electron? 5. Oxygen has 6. Okay. Let me rub this one. It looks like minus. Okay. Oxygen has 6 plus, into 2, 12. So totally there are 17 valence electron. So let us write the structure NO, isn't it? So the possibility here is C, 2 and 4 you have written. Okay, this will be 2. And 1, 2, 3, 4, 5, 6. Just count and see. 17, 2, 4, 6, 8, 10, 12, 14, 16, 17. So this is the Lewis structure of NO2. So how many pi bonds are there? There is 1 pi bond. If there is 1 pi bond, what is the hybridization? The hybridization is sp2. I hope you know that. If there are all are single bond, then we expect that sp3 may be sp3. If there is 1 pi bond, it is sp2. If there are 2 pi bonds, then it is sp. Okay, now we will see NO2 plus. So it is half. Number of valence electrons are 5. Okay, 5 valence electron. So minus 1. 4 by 2, that is 2. So 2 hybrid orbital you can get only by sp hybridization. So in NO2 plus, nitrogen is sp hybridized. Answer is option D. Students, I hope you are understanding. Okay. In case if you have a doubt, write it in the comment box. Okay, we will go to question number 3. The bond angle in HXH is greatest. Now here X can be nitrogen, phosphorus, carbon, okay, or oxygen. So you have to find out among the 4 example, ammonia, phosphine, methane, and in water, where do you see greatest bond angle, the highest bond angle? So if you can see in ammonia, nitrogen is sp3 hybridized. In phosphine, nitrogen is sp3 hybridized. Carbon in methane, sp3 hybridized. In water, oxygen is sp3 hybridized. So in all the 4 cases, student, hybridization remains the same, and that is sp3 hybridization. So you know if it is sp3 hybridization, tetrahedral angle. So how we can find out that the bond angle is greatest? It looks like everywhere the hybridization is same. But we will try to write the possible structure now. For example, if I am writing ammonia, nitrogen has 5 valence electron, right? 3 are involved in bonding and 1 is a lone pair. When there is a lone pair, the structure becomes pyramidal and the bond angle decreases. Okay. Look at phosphine. Phosphine also same family. So it is same story. The bond angle will be, decreases because there is lone pair. In methane, carbon is sp3 hybridized, and if you can see carbon, it is 1s2, 2s2, 2p2. Number of valence electrons are 4 and all the 4 are involved in bonding. So there is no lone pair here. In this case there is no lone pair. So structure remains as tetrahedral and the bond angle will also be the same. There is no reduction in the bond angle. Look at water, H2O. Now here oxygen, atomic number is 8. Configuration becomes 1s2, 2s2, 2p4. So 2, 4 and 8. Valence electrons are 6. There are 6 valence electrons. So out of this 6 valence electron, only 2 are involved in bonding. You can see here 1 and 2. That means there are 2 lone pair. So the bond angle will be still less because water is a bent molecule, V-shaped molecule. The bond angle is very less. So the only possibility is highest bond angle is seen in methane because here there is lone pair. Here there is lone pair and here also there is lone pair. Presence of lone pair always decreases the bond angle, isn't it? Here decreases the bond angle, whereas in methane there are no lone pair, so bond angle is highest. So answer is option C. Okay, we'll go to the next one. The molecule having smallest bond angle is. Okay, now we have to find out the one with the smallest bond angle. Students, do you have some answer? Anyone? Okay. Now which one is having the smallest bond angle? See, nitrogen Okay, I can see Vijay Lakshmi is answering very quickly and saying that the answer is D. Okay. See, nitrogen, phosphorus, arsenic, antimony, bismuth. It belongs to same family, nitrogen family. That means as you go down the group, atomic size increases. Atomic size increases. So if I take NCl3, okay, this is NCl3, correct? And there is one lone pair. And if I take the last one, that is SbCl3, here also you will have a lone pair, isn't it? Now students, see here, as you go down the group, atomic size increases. When the atomic size increases, the electrons are diffused. When I say diffused, student, they are spreaded. They have enough space to be present. The space for them to be present is more, isn't it? As a result, the repulsion will be less. The repulsion between the lone pair and this bond pair will be less. The repulsion between the bond pair and the lone pair, bond pair is also less. So since the size is larger, this is a larger in size, okay? So bond pair repulsion decreases. Because of that, student, what happens is the bond angle will be least. The bond angle decreases. Because if the repulsion is less, they can be present closely. If the repulsion is more, they will like to be present in as far as possible. So since the repulsion decreases here, this will have smaller bond angle or the smallest bond angle. So answer will be option B. If it comes in the exam, you know how you can solve this question, quickly. First of all, conceptually you can solve like how I have explained now, or else you can even remember, see, if these are identical atom and if the central atom is different like this, then bond angle is directly proportional to electronegativity of central atom. Okay, so if you have the atoms which are same here and only if the central atom is different, the bond angle is directly proportional to electronegativity. Nitrogen is more electronegative, so it will have largest bond angle. Here antimony is having least electronegativity, so it has least bond angle. I hope you are understanding. Go to question number 5. In which of the following pairs of molecules, ions, both the species are not likely to exist? So you have to find out among the 4 where you feel the entire, both of them does not exist at all. So students, do you have some answer? Is there any answer from your side? Feel free to give me the answer. And now whenever such question comes, student, okay, whenever such question comes, you have to calculate or find out the bond order. Bond order is number of bonds between two atoms. If there are no bond order, if there are no bond existing, that means such molecule does not exist. Okay. Okay, I can see there are, different answers coming, isn't it? I can see Vijay Lakshmi gives A, Amarnath is saying D. Okay. Students here, now first of all, I told you calculate the bond order. Wherever you find bond order as 0, that is actually such molecule or such ion does not exist. So how to find out bond order? You know that, you know it. Half into number of electrons in BMO minus number of electrons in antibonding molecular orbital. This is a formula. Now look here, we will take option A, H2 minus. When I say single hydrogen, it is 1 electron, 1s1. H2 means there are 2 electrons, minus 1 means 1 more electron added. So the configuration is sigma 1s2, because totally there are 3, sigma star 1s1. I need not calculate, actually you don't have to find out the exact answer. By this one you can make out BMO means this one. Whenever you see this star mark, it is antibonding molecular orbital. So 2 minus 1. So bond order is not 0. That means this exists. I need to find out a pair. Therefore, I need not try this one. They should not exist. That means I am not going to try this one also. So A and C I am not going to try. So let me try with option B. H2 2 plus. H2 2 plus means 1 hydrogen 1 electron, 2 hydrogen 2 electron. When I say 2 plus, remove those 2 electron. So you can say that it is sigma 1s0, sigma star 1s0. There are no electrons, student. Both the electrons are removed. So naturally you are going to get bond order as 0. So there is no bond. This molecule does not exist. This ion does not exist. We will take helium. Now helium 2. Each helium has 2 electron. Helium 2 means 4 electron. So sigma 1s2, sigma star 1s2. So naturally you know it is a half. Number of electrons in BMO is 2 minus number of electrons in antibonding molecular orbital is 2. So 0 will be the answer. So H2 2 plus does not exist. Similarly, He2 also does not exist. Just refresh. If are you watching in mobile? If you are watching in mobile, kindly refresh it, Vijay Lakshmi, because I don't think it's a problem for others. Okay. So He2 molecule also does not exist, and H2 2 plus also does not exist. Okay, because bond order is 0. Now you are not going to learn this problem. You have to learn whatever I have said, that whenever a molecule does not exist means kindly see that whether the bond order is 0. The method you learn. Okay, it is very important that you learn the method and not the that question itself, because it will not be the same question which is going to be asked, isn't it? Okay. During the formation of a chemical bond, very simple question, student. I think we have been learning why a chemical bonding is formed, so I'm very sure that you have the answer. Whenever a bond is formed, chemical bond is formed, you know that in between two atoms, attractive force is generated. When there is an attractive force generated, energy is given out, isn't it? Okay, therefore energy decreases during a chemical bond formation. So during a chemical bond formation, energy decreases. Your answer will be option A. Okay. We'll go to the next one. For a stable molecule, the value of bond order must be negative, positive, 0. There is no relationship between stability and bond order. Students, do you have some answer? Do you have any answer? Okay. We need to remember that, what is bond order? Bond order is number of electrons in BMO minus number of electrons in ABMO. When I say that bond order is, positive, if I say bond order is positive, I have number of electrons more in bonding molecular orbital. When I say bond order is negative, it means that I have more number of electrons in anti-bonding molecular orbital. When I say bonding molecular orbital, suppose if you think this as a nucleus, if this is a nucleus, during bonding molecular orbital, electrons density is in between the nuclei. Since electron density is in between the nuclei, there is an attractive force, operates between the two molecules. There is an attractive force. Because of that, energy decreases and it becomes stable. So more the number of electrons, more the number of electrons in BMO, more will be the stability. When I say more the number of electrons in BMO, I am going to get the bond order as positive. So if I have a positive bond order, that molecule is stable. When I say antibonding molecular orbital, students, the electrons, if you take this as a nuclei, the electrons will not be present in between. Their density will be more away from the nucleus. As a result, the molecules will experience, the atoms will experience repulsion, not attraction. Because of that, the stability decreases. So if the bond order is negative, then the stability is less, and if the bond order is positive, then the stability is more. Answer is option B. Okay, we'll go to the next one. The maximum number of hydrogen bond that a molecule of water can have. So you can try, student, and you can write your answer. Water molecule, the bonds are polar. So H is positive, this is negative, so this is positive, right? So you can expect a hydrogen bonding here. You can expect a hydrogen bonding like this. Oxygen has two lone pairs, right? Okay, if you want, I can write like this. It has a two lone pairs. So it can have, this is delta minus. So this is delta plus. So this can have a hydrogen bonding. So it can have maximum 4 hydrogen bonding, isn't it? With the 2 lone pair and with 2 hydrogen. So total number of bonds can be 4, isn't it? Okay, we'll go to the next one. Which of the following is not characteristic of a covalent compound? You have to find out the property which is not the property of covalent compound. First one is low melting point. Students, when I say covalent compounds are actually having a weak force of attraction. The molecules of covalent compounds, they are attracted by a weak force of attraction. If this is covalent molecule, for example, chlorine and one more chlorine, okay, so there is a very, very weak, I can say, van der Waals force of attraction which usually exist between these molecules. Because of that, they will have generally low melting point. Other than few exceptional cases, usually the force of attraction is weak between these molecules, therefore the melting point is low. This is a correct statement, so this cannot be the answer. No definite geometry. Is it possible, student? No. All the covalent compounds have a definite geometry. You take any compound, they will have a particular geometry. Covalent bonds are directional, they have a particular direction, so they will exhibit a geometry. It can be tetrahedral, it can be anything. So this cannot be the property of actually covalent compound. So this is wrong. That means this is the answer. Covalent compounds have definite geometry. Insoluble in polar solvent. Yes, as we all know, most of the covalent compounds are non-polar, so they will not be soluble in polar solvents like water. Small difference in electronegativity between combining atoms. Yes, of course. Both of them should have very close electronegativity value. If one is more electronegative and other is more electropositive, you expect an ionic bond, not a covalent bond. Therefore, the difference in the electronegativity value should be very, very small, student. Therefore, answer is option B. So students, thank you students for attending the class. If you are liking my class, kindly press the like button, share your valuable comments. My next YouTube session will be on 12th, where I will be starting with S block elements. You can also attend my special classes, which are free classes, where I am doing structure of atom tomorrow at 10 o'clock. So students, keep watching the classes and also preparing for your competitive level exam. Bye students, and take care.